Okay, let's find the relative extrema of f of x is equal to x to the fourth plus 1 over x squared. So relative extrema, we should be thinking, I got to take the derivative to find my critical numbers. Extrema, I got to have a change between increasing and decreasing or vice versa. And then I've got to plug that x value back in to get my y value. Now, when we're talking about taking the derivative of this function right here, if I was just taking the derivative, I would simplify this algebraically first to turn it into more of a power rule as opposed to a quotient rule. Okay, I would rewrite that as x squared plus x to the negative 2 by just putting each term over the denominator and simplifying. X to the fourth over x squared is x squared, 1 over x squared is x to the negative 2. But since I'm finding extrema, since I'm finding critical numbers, it's easier to keep this in fraction form because then I can just set my numerator equal to 0 and my denominator equal to 0. So let's do that. F prime of x is equal to low d high minus high d low, all over low squared. So let's simplify things a bit here. We've got 4x to the fifth. Remember your exponent rules, you add those exponents. Minus 2x to the fifth minus 2x. So I just distributed a negative 2x to the x to the fourth plus 1. And that's over x to the fourth. And we can simplify that just a smidge more. 4x to the fifth minus 2x to the fifth is 2x to the fifth. So there's my derivative. Critical numbers come from where the derivative is equal to 0, in this case where the numerator equals 0, and where the derivative is undefined, where the denominator equals 0. So let's set each of these equal to 0. See what we come up with. This is a polynomial. We need to factor. We can take out a 2x. We end up with x to the fourth minus 1 is equal to 0. So we've got 2x, and that'll factor further. X squared plus 1, x squared minus 1. It's the difference of perfect squares. It will factor just a little bit more. Okay, x squared plus 1 is not factorable. X squared minus 1 is. X plus 1 times x minus 1. So that says that we have critical numbers at x equals 0. I just ignored the 2 part. X squared plus 1 is never going to equal 0. And then we've got negative 1 and positive 1. And then if we set the denominator equal to 0, we end up with the x equals 0 part again. All right, so we've got our critical numbers, so we need to set up our number line. We've got negative 1, 0, and positive 1. I'm going to plug in negative 2, negative 0.5, positive 0.5, and positive 2, plugging this into our derivative right here. Just as a reminder, I'm not really concerned about what the numbers are. I'm just concerned about whether they're going to be positive or negative. So when I plug in negative 2, and I raise that to the fifth power, that's going to give me a pretty big negative number, specifically, negative 32. And I multiply that by 2, so I get negative 64. And then I'm adding 4 to that. That's going to be negative. The denominator, negative 2 to the fourth, is positive, so I am negative until I get to negative 1. If I plug in negative 1/2, okay, negative 1/2 raised to the fifth power is a negative number, a very small negative number. Multiply it by 2, still a pretty small negative number. Then I'm adding 1 to that, so I believe that that's going to end up being a positive number. So positive over positive is positive. When we plug in positive 1/2, we're going to end up with a pretty small positive number, 2x to the fifth. That's going to be a pretty small positive number. Minus 1, I think that's going to give us a negative number over a positive, so that's going to give us negative. And when we plug in positive 2, we're going to get a really big positive number in the numerator over positive, so that's going to be a positive. So we see a sign change at each of our critical numbers, at -1, at 0, and at +1. So we need to go back and plug these into x to the fourth plus 1 over x squared. We're plugging in -1, 0, and 1. So when we plug in -1 to the fourth plus 1 over -1 squared, -1 to the fourth is -1. -1 squared is +1. So -1 plus 1 is 0. 0 divided by 1 is 0. Guess what? Same thing's going to happen when we plug in +1. We're going to get, well, not the same thing, excuse me. Oh, that's positive. My bad. Let's go back just a little bit. I'm getting in too much of a rush. -1 to the fourth power is +1. +1 plus 1 is 2. So let's see here. What happened at -1? We changed from negative to positive, which means we changed from decreasing to increasing. So we have a minimum at -1, +2. We are going to end up with the same thing when we plug in +1. We're going to get +2, but at +1, same thing happens. We change from decreasing to increasing, so that's another minimum at +1, +2. So this seems a little strange. I haven't checked 0 yet. When I plug in 0, 0 to the fourth plus 1, I get 0 in the denominator. That's undefined. So even though 0 is a critical number, it does not produce a maximum or a minimum. Let's look at the graph of this just to make sure that we've got everything right while we're in the learning stages here. You would have to do this without a calculator on the exam, but we're just trying to make sure that we've got this down pat. So let's use our resources. Look at the graph. Okay, so we can see here's that minimum at -1, +2. Here's what's going on at 0. 0 is a vertical asymptote. Okay, so that means it's never going to be a maximum or a minimum, but we can have some changes there. And then at +1, +2, we have another minimum. Okay, so a couple of things to see in that problem there. Let's look at one more. Let's find the relative extrema of this cubic function. Okay, same thing still applies. We're going to take our derivative. We're going to find where it's 0 or undefined. It's a polynomial. It's never going to be undefined. But the derivative here, 1/3 x cubed. So 1/3 times 3 is 1. So that's just going to give us x squared minus 2x plus 1. So we're going to set this equal to 0. It's a quadratic. It's equal to 0. So let's go ahead and factor it. X minus 1 times x minus 1. So we get a repeated root. We have a critical number at +1. Let's see if we've got any change. I'm going to test 0 and 2. Remember, I'm plugging this into the derivative. Okay, this is at f prime. So when we plug in 0, we get 0 minus 0 plus 1. So that's positive. When we plug in 2, 2 squared is 4. Minus 2 times 2 is 4. 4 minus 0 is 0. Plus 1 is positive. So we have no sign change. Okay, so that's a critical number, but there's no sign change. So that means no relative extrema for this one. No relative extrema. And just for review, if we were listing the increasing and decreasing intervals, this one would be increasing from -infinity to 1 and from 1 to +infinity. That's how we express that critical number at +1. So even though there's not an extrema there, it's neither increasing nor decreasing at +1. So you got to cut off that interval at 1 and use those parentheses. That's how they would express that. Since this one's a little weird too, let's go ahead and graph it and make sure that we didn't do anything crazy. 1/3 x cubed minus x squared plus x. Let's look at the graph. Here comes the cubic function. And notice that flat spot there at 1. That's a horizontal tangent line. So it's not a maximum or a minimum because we don't change from increasing to decreasing, but that's a good example of a horizontal tangent line. We could even zoom in on that a little bit so we can see some more detail where it flattens out. But there's no maximum or minimum. So that's why the derivative does equal 0 at 1. It does equal 0 at 1. We do have a horizontal tangent line, but that horizontal tangent line is not a maximum or minimum. Okay, so that's something to keep in the back of your head. Even though the derivative equals 0, even though some x value is a critical number, critical numbers do not guarantee maximums and minimums. Now, if it is a maximum or a minimum, it is a critical number. Okay, so if they tell you it's a maximum or a minimum, if a max or a min, you do know that it is a critical number. It is a critical number. Okay, if a critical number, it's not always a maximum or a minimum. Most of the time it is, but not always. Okay, most of the time it is, but not always. So keep that in your mind when you're answering some of these, which of the following statements are true kind of questions. All right, so here's your practice on the first derivative test here. Work out those textbook problems and you will be ready to tackle that 12 weeks test.